Okay, it looks like we're back. Or I hope we're back at least. I'm not entirely certain. It says I'm sending data, but I don't know what happened. So I think Twitch is having a little bit of trouble lately with everyone at home using their service. Anywho, here in Philosophy Roulette 91, and we're looking for a paper to read, and we're at the British Journal of Aesthetics forthcoming papers. So. Oh, nothing. Oh, they don't have page numbers on their forthcoming ones. That's too bad. I'm not searching for something with no page numbers. Let's see. This is interesting. Got two icons here. This Continental Philosophy Review. Let's see what they have for forthcoming, if they have page numbers on it or not. So, is this a review, or is this from the Great Witch Hunt to Terror and Present-Day Jihadism? Well, let's see if this is available, because it's only supposed to be 9 pages. I could handle 9 pages. At least I hope I could. So, let's find out. Ooh, it might be a open access. Nope. That's too bad. Temporality and self-embodied presence. And embodied self-presence. Let's see, I could handle some embodied self-presence right now. Nope. That's unfortunate. What is this? Oh, this is AJP. Okay. Six pages review. 8 pages unassailable heritage. Jean Walls. Is too much French for me. What was I looking at it on AJP? I thought there were like something interesting. Oh no! Why does that happen? Anywho, no big deal. Dynamic non-classicality. Oh, the Mandelkran, that's right. Let's see, do I have that here? I probably need to take a look at that paper just because I'm a little concerned with some of the stuff that guy talks about. Review redundant reasons. Making quasi, it sounds a little too much for me. Paradigmatic Metaphysics. The Stoics unlike all there is to say. Katya Vogt. Wait, I think she's here in New York. I might have run into her at some different point. Yeah, Columbia. So let's see if this is available. Do the New York person first. Oh, this is a review. Okay, that's fine. I was wondering why it was so short. This one, Paradigmatic Metaphysics. Let's see what else we got. $14 pages. Let's see how, and it's double spaced. I can handle 14 pages of double spacing. That's good. But my internet is being real flaky at the moment. I don't like this, not one little bit. Okay, and we're up and running, so good. sure hope this is broadcasting. It kind of says it is, it kind of says it isn't. Don't quite know. But hey, that's how these things go. If you ever are here in the chat with me, you can grab the link in the chat by typing !paper into the chat box. And that link will pop right back up. And of course, the chat, everything decided to go break again today. Okay, so it looks like it's up. And let's see, is everything else ready? No, not entirely. Let's get a title. Alex Steinberg, Paradigmatic Metaphysics. I wonder if that's like dogmatic metaphysics. It doesn't matter, we're going to find out. Introduction. Christian Nimtz, 2017 and forthcoming, argues that the semantic notion of paradigm termhood is at the core of Kripkean philosophy of language and metaphysics. Paradigm termhood, okay. The Kripkean aims at finding a feature of proper names and natural kind terms that can explain certain shared modal features, in particular the necessity of identifications. Following Kripke 80, this feature is often taken to be rigidity. However, Nimtz argues that, while rigidity cannot be generalized from the case of singular terms to cover all relevant cases, whilst fulfilling its intended explanatory purpose, the notion of paradigm termhood is easily so extended. According to Nimtz, paradigm termhood of natural kind terms is a main ingredient in the explanation of why theoretical identifications such as all and only tigers belong to clade part, to clade point? I don't know what that is. And all only sample waters are samples of H2O. So I guess this would be a clade point semicolon. Don't know, maybe that's just the tiger genus or one of those biological distinctions that only tigers exist in. Aren't necessarily true. Nimtz takes this to be a deflationary result. No serious metaphysics, but only semantics and science are needed to establish natural kind essentialism. If Nimtz is correct, the notion of paradigm termhood is of central importance to the Kripkean project and to the philosophy of natural kinds in general. It is all the more important to get clear about it. The present note separates pertinent logical from extra-logical considerations, thereby helping to assess Nimtz's deflationary claim. It will turn out that establishing the necessity of theoretical identification requires a substantial metaphysical assumption after all. I sure hope I got a good bit right here. I can't quite tell, but we'll see. Paradigm terms. According to Nimtz, natural language proper names and natural kind terms are paradigm terms. A paradigm term is a term that applies to something at a world just in case that thing stands in a certain equivalence relation to a certain set of paradigms for that term. Thus, for instance, the term is as long as stick A is at the actual world is a paradigm term, since whether it applies to something X at world W depends on whether at world W X stands in the same length relation to the paradigm A at the actual world. Alright, so these are taking them to be some sort of standard, I guess. That's what they mean by paradigm. If it's as long as a stick, that's a standard measuring stick, and so that's the paradigmatic one that everything else is measured off of. Let us be a bit more precise here. In a Kripkean framework, in which individuals are not world-bound, but the underlying equivalence relation is most easily conceptualized as a relation between object-world pairs. Alright, so we've got some logic-y stuff here, like lambda x w, y w prime at w, x is as long as y at w. Okay. In general, a paradigm term will have an underlying equivalence relation between object-world pairs and an associated paradigm set that includes an object-world pair xw in angle brackets, just in case x at w serves as a paradigm for the term. In our case, we assume that the paradigm set consists solely of a at symbol. So this is the usually like the actual world, so the thing at the actual world. While our example was chosen to be a paradigm case of a paradigm term, NIMS defends the more interesting empirical hypothesis that natural kinds predicates, like is a tiger and is a sample of water, are paradigm terms as well, which is supposed to explain why theoretical identifications like 1 and 2 are necessary if true. To avoid complications, we will stick to our maximally explicit case for now and remind ourselves of some logical properties of the underlying equivalence relation. Okay. Whether a paradigm term applies to an object at a world depends on whether the object-world pair stands in the underlying equivalence relation to the elements of the paradigm set. To simplify matters, let's assume we can identify n-place relations with sets of n-ary tuples. In particular, a two-place relation will be identified with the set of pairs whose first element stands in the relation to the second, a one-place relation, also known as property, with a set of objects that exemplify it. Okay, so a relation is the two-place identified with the pairs at the stand relation, and the second is the property of the thing. Okay, a two-place relation is an equivalence relation on the field, just in case it is symmetric and transitive on its field. An equivalence relation R partitions its field into mutually exclusive and jointly exhaustive sets, the R equivalence classes. If X is an element of the field of the equivalence relation R, the R equivalences of class X, square brackets R of sub X is the set of objects that X stands in R2. Definition. Alright, so the Ry such that Rxy. Since R sub X is a set of objects, we can take it to represent a property. The relational property standing in R2X. Let us call the set of R equivalence classes for an equivalence relation R rho R. Equivalence relation R, the rho R. So, okay. Rho R is defined as some delta that exists in the field of R, and delta is the set of all the things in that R. Okay, so there is some thing in that field, because that's the claim here. It is a basic result of the theory of relations that for any equivalence relation R, rho R partitions field R. So yeah, so there's something that is part of all of the pieces here for some relation. This immediately entails that objects are R related, just in case there is an R equivalence class they both belong to. Further, no object belongs to more than one R equivalence class. Let's label these results in terms of the properties we identified with R equivalence classes. Theorem 1. For every equivalence relation R and object X and Y are R related, just in case there is a property P is an element of rho of R such that X and Y share. So if they have the same equivalence relation, then they stand in this relation to each other. For every equivalence relation R and all properties P prime elements of rho of R, or I guess that might just be an italic, depending on the typeface here. If an object has both P and P prime, then P is equal to P prime. Okay, so if they're if they're both in the same equivalence relation, then they are identical, the property. So there's some sort of extensional definition here. It is a straightforward consequence of theorems 1 and 2 that whenever things are related and one of them has a property in rho of R, the second does too. That is, theorem 3, for every equivalence relation R, every property P in the element of the properties of R, rho R, and all objects X and Y, if Rxy and Py, then Px. So if these two are equivalent, then one has the property, then so does the other. Okay. Since the underlying relation of a paradigm term is in an equivalence relation, the above considerations apply to them. In our example, in the underlying relation of the paradigm term is as long as A is in the actual world. So, formula at A in the world is an equivalence relation. So you're defining the world in terms of this property of A is as long as. Thus, it partitions its field into properties, each exemplified by at least one object-world pair, such that an object-world pair stands in is as long as A is in the actual. Is there anything exactly as long as A? I mean, depends on how you're measuring, but that's a different problem, I guess. Such that object world stands in S to a second, just in case both have one of those properties. We can specify these properties in S relationally as properties of the kind standing in S2, so BV for some BV in the field of S. So it is plausible that with nymphs we can also specify them as the exact length properties of the kind being exactly so and so long, or more precisely lambda xw, x is so and so long at w. This will be just so in case for each S x w, there is an exact length property P such that an object role pair is an element of S x w, just in case it exemplifies P. I mean, I don't know if length is the best. I mean, it seems like a simple example, but always these sciencey things don't turn out to be anywhere near as simple as you think they are. Because I mean, the only thing that's exactly as big as the standard meter is the standard meter, and even that, or we should go with the kilogram, because I think although we may have just changed, I think we might still just be on the block of metal in Paris. There's a block of metal of Paris, that's the kilogram, and like I think they may have just changed it last year or a year or two ago, but like let's just pretend that didn't happen, because I can't even remember if it did happen. The block of metal in Paris, it's a tungsten ingot or something, some very stable metal, is the kilogram. And so any other kilogram is measured off that thing. No other thing is exactly that thing. You just can't be. And the problem is little bits of the metal like evaporate and like land on it. And so at that point, the actual weight fluctuates. So the exact weight of that, the exact mass of that piece of metal that is the kilogram is changing. And so there is no such thing as a property like that can be defined like this. I'm sure some smart people have come up with smart ways to do stuff about it, but it's just that these sort of standard things off what you think are fundamental properties of the universe, they get immensely complicated and difficult to actually pin down if you were trying to be exact about it. So this is a minor worry that there is only one thing that is exactly so and so long, and so this isn't, in some sorts, is not an equivalence class except for the identity relation where everything is only self-identical. Okay, so that's one minor gripe with this sort of setup using this example, but I don't think it has it's going to be anywhere near critical for the paper in general. It's just a minor gripe over here. This result shows that NIM's generalization from the case of S in the set of exact length properties is safe. Well, not according to me safe, but it's reasonably safe. He writes, I understand the case of the relation of having the same length and the same set of determinate length properties to generalize. That is, for an underlying relation R, there's a family phi of determinate properties controlling whether the relation holds between two items, such that relation R holds between x and y if and only if f, x, and y instantiate the same determinate property, little phi of big phi. NIM's family big phi, what he goes on to call the family of realizers of the equivalence relation R, simply is our rho R, which by theorem 1 is guaranteed to exist and behaves the way NIMS envisages. Okay, so you've defined NIMS's realizers in the logic above, which is cool. Paradigm terms and identification. Theorem 2 states that the properties of rho R, or this realizers, are mutually exclusive. If P and P prime are elements of the realizers and an object has both P, P is the same as P prime. This can be used to show that, given suitable further assumptions, theoretical identifications like 1 and 2 are necessary, a view called natural kind essentialism. Here's a reconstruction of the type of argument NIMS provides for our paradigm term. Is as long as A is at the actual world, abbreviated is F, and a descriptive predicate such as is exactly 1 meter long is abbreviated G. So as long as A is F and 1 meter is G. Okay. Assumption 1. If F is a paradigm term 1, for all x w, is F applies. So is F is just as long as A applies to x at W if and only if for so you've got this S, I forget what that is, but x at this world is the same as A in the actual world. Okay. Assumption 2. F is a paradigm term 2, so that makes S is an equivalence relation. So these two things are equivalent. Assumption 3, G is a descriptive term. Okay. For all x, W is G, so that means 1 meter long. Applies to x W if and only if lambda y W prime y is G at W x W. So I guess that's exactly 1 meter, and it's described by this little formula here. That's fine. Assumption 4. So this is an S realizer. So this is realizing the relation of G. So at the world, then Y is G at W. So that realizes G. So that shows that it is the same. It is 1 meter long. Okay, and is F applies to something in the world, so this existence claim. So there is something, there exists X, W, applies at X at W. Alright, so X is F, and is G apply to the same object in the actual world? So now X is F, and X is if and only if is X is F and X is G. Okay, applies to the same things at the same world. And then assumption 7, modal semantic descent. For all X, W is F applies at X at W, to X at W, if and only if is G applies to X at W, implies that necessarily that is the case, because and it takes out the so all worlds. So it drops the world and makes it necessary as to say all worlds that X is F and if only if X is G. The argument is so straightforward that I spare you the details. In a nutshell, drawing on assumptions 1, 2, and 5, okay, so now they're just going to repeat what I just tried to say. We first show that is F applies to the F paradigm at A at the actual world, so something is the same size as A at the actual world. Drawing on line 1 in assumption 3 and 6, we then show that A also has a property semantically related to the descriptive term is G at the actual world. So you can also do that. On this basis, we show that an antecedent of assumption 7 holds for is F. So if is F applies to an arbitrary chosen object C at an arbitrary world V, by assumption 1, CV stands to S to a thing A at the actual world, thus applying theorem 2 with line 2. CV has G-ness, so that means it is of the size of 1 meter. With assumption 3, we conclude if is F applies to C at V, is G also applies. So if they're equal to the same thing, so if C is equal to something and then that is equal to something else, the other thing also applies. If on the other hand, if G applies to C at V with assumption 3 and 4, line 2, C bracket CV shares an S realizer property, so it's realized it does actually exist at the actual world with A, and thus theorem 1 stands in S to A at the actual world, so it is of the same length as A. And with assumption 2, we conclude if G applies to CV, is F applies to. With assumption 7, we finally arrive at the essentialist claim regarding being just as long as A in the actual world. So that is the more general claim. It's necessarily the case for every world is that anything that is F is G, so if it's as long as A, then it is 1 meter. So if it is just as if it's equal to the kilogram thing, then it is equal to if it's equal to the standard kilogram in France, then it is equal to 1 kilogram. And that's how we make measurements in the SI system. In summary, from assumptions 1 to 7, we can show with a little bit of help from the theory of equivalence relations that the quantified biconditional containing the paradigm term is as long as A is in the actual world, and the descriptive term is exactly 1 meter long is necessary. I don't know what you show. From assumptions we can show. I mean, the assumptions are kind of set up to do this. What's the entire point of this? Let's find out. Clearly, provided that the assumptions are justified for them, we can run analogous arguments for any other paradigm and descriptive terms we care to choose. Sure, so for all sort of measurement sort of thingies, we can do the same sort of thing. Alright, let's see what hay is made out of all this setup now. Consequences for metaphysics. Nymphs takes the results sketched in the last second section to have important deflationary consequences for the theory of natural kinds. Since he argues the assumptions that the argument relies on are in part semantic, in part scientific, none by itself has non-trivial essentialist import. Nymphs claims that we can establish natural kind essentialism for kinds such as water, gold, star, or tiger without reliance on essentialist premises. All this requires our insights from semantics and from science. Alright, let's see. Because, I mean, like I was just saying a second ago, I mean, you set it up that way. So it's like, if you set up your semantics to give you that, then you're also going to get that. But that doesn't prove anything because you set it up that way. You'd have to show that somehow the way you set up was independent of these already, of what you were trying to show. Now, granted, I'm sure maybe I missed something, but you'd have to be more explicit about what the essentialist premises are and how they do not apply to what was said above. Okay, though I agree with Nimps that the argument provides an interesting route to the conclusion that biconditionals such as 1 and 2 are necessary, I disagree with him about its deflationary import. Okay, so the author also has questions. Our reconstruction clearly shows the place of serious metaphysics in the argument, even if we agree that assumptions 1, 3, and 7 are semantic, that assumptions 5 and 6 can be established by science, and that assumption 2 is a logical truth from the theory of relations. This leaves assumption 4. It is a consequence of the theory of relations, and thus we may take it to be a logical truth that there is a realizer set of any equivalence relations S, and that there is an element of P of S shared by everything that stands in S to a given object-world pair. But it is neither a semantic, scientific, nor logical truth that the property specified as the property of being an object-world pair whose object component is G at its world component is an element of PS to the relevant G. Serious metaphysics about what it takes for object-world pairs to stand in S to one another is required to establish this assumption. Okay, so I guess what this is saying is even if you have stuff in the world and all the logic and all the science, it doesn't mean that the property you're ascribing to the world, whose thing that you're trying to establish, this is still unjustified, that the actual relation that you're specifying, the property as a property of being an object-world pair whose object is component G, the G, which was, remember, being 1 meter. So you have to, there's no guarantee that the thing you're specifying is part of that equivalence relation. I mean, you kind of defined it that way, but does it actually exist? Or is it metaphysically required? So serious metaphysics about what it takes for object-world pairs to stand in S to one another is required to establish this assumption. So is the property you're saying actually the property that exists in the world in some way? Consider what it means that a given property P of the kind realizes, a P of the kind specified is an S realizes, so it is an actual property in the world. It has to be the case that there is some object-world pair such that for any object-world pair, since in that just in case of these things share P, that is just in case X there is G, so X is 1 meter long and Y is W. X is G, so X is 1 meter at some world and Y is G at world prime. The theory of relations assured thus for each object-world pair that is S related at all, there's an instance of G that fits the bill, namely such that they stand in S 2x at W. But this is not the sort of instance relation for the theoretical identifications at issue. Why not? I mean, they were saying that the paradigmatic case, this is the sort of thing, but this G is a sort of a generalized property that you are matching something to, so maybe there is not some sort of generalized paradigmatic case that you can guarantee has an object-world pair. Okay, that makes some sense. That how do you know what your properties are that property actually does obtain? Okay. Instance relevant for the theory of identifications at use. So you've got some sort of property existence that has to go along with the theoretical identifications, the names of things. All right. So in the case of 1, according to Nimps, the underlying equivalence relation, something like a W at W, X belongs to the same natural kind as Y at W prime, and the canon of being S realizer. So W, something at W, X belongs to the clade, so the tiger is part of the PT clade. It is certainly not a semantic truth that Q is an element of the realizer set of S, since this claim does not concern linguistic expression at all. Neither is a consequence of the theory of relations by itself. Finally, it does not seem to be the kind of truth that can be established by science either, since it has non-trivial trans-world implications. It does not it does not only imply that two things at the actual world belong to the same natural kind if they both belong to the clade PT at the actual world. It implies the analog for any possible object at any possible world. Okay, because this is some sort of generic property. So it applies for any possible object, any possible world, that, like, if you are part of the clade PT, then you're a tiger, but this is the existence of the property across all possible worlds. Okay. Given that actual science is aimed at actuality, it's hard to see how it could uncover such trans-world claims unaided by metaphysics. To be sure, we might very well think that science tells us that at the actual world, all things that belong to clade PT belong to the same natural kind, while, for example, not all things that have stripes belong to the same natural kind, because there are tigers and race edition Mini Coopers, for instance. I guess they both have stripes. I haven't seen a race edition Mini Cooper, though. This is insufficient to exclude enough candidates for the job of being an S-realizer, since there are infinitely many properties that agree with Q on actuality but disagree with Q on other possible worlds. Theorem 2 assures that only one of them can be an S-realizer set, but science does not appear to be able to distinguish between the candidates. So science by itself does not decide the issue. Yeah, science does not decide what are on non-actual worlds. The help of serious metaphysics is needed. Perhaps there is a plausible principle that if being F is such and so, and all objects that are F at the actual world are S related at the actual world, then all possible objects that are F at their respective worlds are trans world S related. So it's a well, you're generalizing from an actual world to making it a necessary metaphysical truth. Seems unlikely. If there is, we could enlist the help of that principle together with the actual truth of the biconditional and the further assumption that Q is such and so to argue that Q is an S-realizer. But whatever that principle might be, for it to cover the cases at hand, it would have to be discovered by metaphysics, not semantic, logic, or science. Yeah, that'd be a very strong metaphysical claim. Analogous claims hold true in the case of 2 and any other empirically established theoretical identification. Let me end by noting the disanalogy to proper names. Though, as argued by Nimps, both proper names and natural kind predicates may be paradigm terms, the analogous argument for the necessity of identity statements involving proper names does not require a metaphysically loaded assumption. For according to Nimps, in the case of proper names, the underlying equivalence relation is identity. Accordingly, we can run the argument for the view that it is necessary that A equals B, provided it is true in terms of the identity relation at A, for A. And as we have seen in the discussion above, it is a consequence of the theory that relations such as identity for some x is an element of row equivalence for any x that is identity related at all. Since further we might take it to be a logical truth that everything is identity related, no additional metaphysical assumption is needed to establish that it is necessary that A equals B via the paradigm termhood of A and B. Okay. So yeah, so if you've got if things are these property relations, I mean, if you've got special ones like identity, that's some sort of I mean, I don't know if it does not require a metaphysically loaded assumption. Well, you're making there's a lot of sort of assumptions having to do with the identity relation right there. So it's not metaphysically loaded because we assume it already, but that does not mean it doesn't have any non-trivial assumptions going along with it. What exactly does identity come down to is not especially in terms of metaphysics. Well, I mean, that's a different paper. So I'm not. You don't have to make any unusual metaphysical assumptions, but I mean, this may still be metaphysically loaded, but that's no big deal really in the course of this paper. Okay, I conclude that while the route to natural kind essentialism via paradigm termhood is an interesting one that deserves exploration, it is unable to avoid having to dirty one's hands. Semantic science and the theory of relations may help to establish the necessity of theoretical identifications, but serious metaphysics is needed to complete the case. Whether this is good or bad news for natural kind essentialism remains to be determined. Okay, so this is saying you're not getting a free lunch by this sort of paradigm termhood. You still have to do a lot of metaphysical work, and even though it's a little bit buried, the author unpacked it, I think, in a reasonably nice way. Granted, this sort of paper is not for everybody, but for people who are worried about this sort of cross-world identification, and if you try to go this route, you still end up having to have some sort of weird arbitrary property universalism, which they probably don't want. That would seem a little bit it pulls in too much metaphysics and would seem to be the anti-naturalist sort of streak that runs through this sort of theory. So, okay. But other than that, it was a nice paper for just reasonably clear given the subject matter and the logic that it had to use to make its point. So that's nice. Yeah. Okay. So that's it for now. I hope everyone has a good night, stays safe, and I guess I'll be back in the morning. Have a good night, folks. Good morning, whatever it is. Stay safe. Bye.